solve the matrix equation. First, we have the matrix 2, 1, 4, 3. That is multiplied by the matrix RS, TU, and the result is the matrix 2, 1, 4, negative 1. Place the equation under the microscope. It is the same equation that we had before, and we are required to find RS, TU. That is what we are required to find. What do we do? In solving this equation, we need to eliminate the matrix that we already know as M from the left-hand side. We will eliminate this matrix from the left-hand side, then we will have this matrix being equal to the result that we will have on the right-hand side. How do we do that? That matrix we already know to be M because we used this in a previous section to this problem. To eliminate M, we need to multiply by M inverse, which is of course the inverse of M. That we already found on the left-hand side. Not that we found it on the left-hand side, but we need to eliminate it from the left-hand side, and we already found M inverse that we will use to eliminate this matrix M. We will multiply by the inverse of this matrix on the left-hand side, and to keep the equation balanced, we need to multiply by that same matrix on the right-hand side. Whatever we do to change the value of one side of an equation must be done to change the value of the other side in the same way. We will therefore multiply by M inverse on both sides. To eliminate this matrix from the left-hand side and on this side to balance the equation. Matrix multiplication is not commutative. Therefore, since M inverse was placed first in the product on the left-hand side, it also has to be placed first on the right-hand side. The order in which we multiply matrices will affect the result. Therefore, we have to be careful. If we multiplied by M inverse first, it is the first matrix in the product on the left-hand side. It also has to be the first matrix in the product on the right-hand side. And that is why it is necessary for us to shuffle this matrix a little bit over in order to make provision for it to be the first matrix in the product on the right-hand side. Matrix multiplication is not commutative, and that is why we had to do it that way. So we have right here M inverse, and we have it here also. We had previously labeled this one M because it is the matrix that we knew before to be M. Now we showed that M times M inverse is equal to I. If we multiply a matrix by its inverse in any order, the identity matrix will be the result. Therefore, the left-hand side will be simplified to this product that we have here being the identity, which is 1001, and of course we will maintain our matrix of unknowns, RSTU. The right-hand side is not affected as yet. Also, any matrix multiplied by the identity is equal to that same matrix. There is therefore a further simplification of the left-hand side with the identity times this matrix being just equal to this matrix. Any matrix multiplied by the identity is equal to that same matrix. Is a further simplification of that left hand side. Therefore, all that we have on that left hand side is RSTU. That's fine. Everything else is eliminated from that left hand side. Now we need to find the result of the right hand side so that we can equate it to RSTU, and we will not do that immediately. We will do that on a subsequent slide. Finish by finding the matrix product of the right hand side. We need to do that in order to find the values of these unknowns. We will now find the product of the right hand side. Because of the limited space, the left hand side is not shown immediately, but it will be shown as soon as we are ready for it, as soon as the product is found. Notice that what we have is the right hand side of the equation, and we are not showing the left. We are just leaving it out. The left is left out at the moment. We will include that a little bit later. The emphasis should be on this product, and we will go straight ahead. The half takes its place, and we will continue with our favorite. The upper row by the left column, the answer will go to the upper left. The first times the first, 3 times 2. The second times the second, -1 times 4. We will maintain the position or our position in that upper row, and we will move to the right column. The answer will go to the upper right. The first times the first, 3 times 1. The second times the second will be -1 times -1. Since we use the upper row to exhaust both columns, we will now move down to the lower row. The lower times the left, the answer will go to the lower left. And no doubt, -4 times 2 will be the first times the first. The second times the second will be 2 times 4. Finally, remaining at that lower row, we go over to the right column. The first times the first, which is -4 times 1, then the second times the second, which will be 2 times -1. Then our simplification process continues with these sums of products. 6 minus 4, that will be 2. 6 minus 4. Then the next one will be 3. Don't forget, negative times negative is positive. Therefore, that will be 3 plus 1. Then, that will be -8 plus 8. And finally, -4 minus 2. Each product is a product of a negative and a positive. The result will be negative in both cases. -4 minus 2. Then, 6 minus 4 is 2. 3 plus 1, that's 4. -8 plus 8 is 0. And this is the one that students might have a second thought about. -4 minus 2. That will be -6. And we will enjoy the simplification process from here on, because these numbers are all even numbers, and we are required to multiply by a half, which is the same as dividing by 2. now that we have the space for our left hand side, we will have it included right here. This intermediate step is not completely necessary because we can see that a half of 2 is 1, a half of 4 is 2, a half of 0 is 0, and a half of negative 6 is negative 3. When we have unknowns, it is not good enough just to leave our answer like that. We are required to solve the equation. It is not appropriate to leave the result in matrix form, but to write the value of each of the previously unknown. Now they are known. It is not good enough to say RSTU is equal to 1, 2, 0, negative 3. But if we have different unknowns, we should state the value of each. R is equal to 1. S is equal to 2. T is equal to 0. And U is equal to negative 3. And some may say that that is bad English, that U is equal to negative 3. The letter U is equal to negative 3, and we are not talking a person, in which event we will say you are, but it is the letter U, and that is equal to negative 3. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.